Hi, welcome to the Chapter 4 Microlecture Hardware and Software. So what does a manager need to know about hardware? Basically, we've got four things. We've got storage, which can be our disk, it could be tape, it could be DVD-ROM. We've got our different types of inputs. We've got keyboards, mice, scanners, UPCs, microphones. The CPU is going to do all the processing. It's going to convert everything that's in storage, everything you're getting from your keyboard or your mouse or things like that, all your inputs, into some kind of program. And then that's going to turn it into output, whether it's on your video display, through your printer, through your speakers. But you're going to basically turn your input and your programs out of storage into some kind of output. How does a computer work? It's got a few basic components. First of all is the CPU. That's the basic processing unit. That's really the engine inside your computer. If you go to Dell or HP and you go to build a computer, this is really the one component you can't ever upgrade. Typically this is done in gigahertz, and you'll see, 1.7 gigahertz, 2.2 gigahertz, no. And it's going to move instructions in and out of the main memory. So basically, it's going to be the engine. You're going to feed it, it's going to process, and then it's going to move out. Main memory is going to contain all of the program's instructions. It's going to have all the operating system instructions. It's going to basically tell the computer, hey, this is how you want to work. So let's take a look at your operating system. What is it? For most of us, it's Windows, whether it's Windows XP or it's Windows 2000 or Windows 7 or Windows Vista. For some of us, it's Mac operating system, and we'll talk about this. But this is the program that controls the computer's resources. It's going to say, hey, I've got a video card and this is how I use it. I've got a mouse and this is how I use it. I've got Microsoft Word and this is how I use it. The operating system is the core of the computer. It's really the foundation that your computer is built on. So now we can look at what's the difference between a client and a server, right? Client computers are going to be used for word processing, spreadsheets, database. The difference between a client and a server. In reality, the only difference is the software that the computer is running. I could take the desktop or the laptop that I'm doing this PowerPoint on, I can install Windows Server 2008 on here, and I could turn this computer into a server. But in the book's definition, servers, and in reality, servers often have much larger resources than a typical desktop. So if my desktop has got 8 gig of memory, well, a server may have 64 gig of memory. It may have more memory so that it can process more functions. Typically, they're faster. Sometimes they have 2 and 3 and 4 processors. And they have very simple video displays. They're really not designed to do graphics. You never install Microsoft Office or anything else on there. They just run the server. If you have a collection of servers, you can call these a server farm or a server grid. And places like Google, Amazon, Delta, they have giant server grids to run their entire sort of back-end infrastructure, back-end system. So what does a manager need to know about software? Well, we've got two different types of software. We've got the operating system, which is sort of that core instruction set. And then we have application programs like Microsoft Office or QuickBooks or Word or things like that. So the application program is really what people would call the personal productivity software. I need to do something on a computer. I need a piece of personal productivity software. I need Photoshop. I need something like that. So what does a personal productivity software need? Well, it only runs on certain operating systems. If you go to Best Buy or you go to Staples and you go to buy a piece of software, you look on the side of the box and you say, hey, this runs on Windows 7, this runs on Windows XP, this runs on Mac OS. Okay, that's what I've got. So you have to make sure that the software is set up to run on what your computer is. When we look at the operating systems, 85% of the world is Windows, and that's actually down. It used to be about 92%. 95% is business users. And so if you look at Central, you look at other schools and colleges, you look at the bulk of what gets sold minus what gets sold out of the Apple Store, and it's all going to be running Windows. That's the most common and most popular desktop we've got. Mac operating system, certainly developed by Apple, and it's been growing. I mean, the success of things like the iPhone, some of the entry-level Macs like the iMac Mini, and the PowerBook have made it easy to use. It's supposed to be sold as a computer your grandmother can use. Something new is Mac operating system now runs on the Intel processor. So whereas before you could have an Apple and it would only run Mac OS, now you can have an Apple and it'll run the Mac OS or Windows. And so that's kind of cool, but you're still probably paying $3,000 for a Mac laptop, and you could get a Windows knockoff for about $1,000. There's a couple other operating systems that you may not have seen. One is called Unix, and it's been around forever. And it's really just a workhorse. Most giant databases, most giant implementations are going to be run on Unix. If you think about the WebCT Vista or Blackboard Vista run by Central Connecticut, that's all a Unix cluster. It's actually 12 different Unix machines, and it's serving about 20,000 students. So if you're going to serve 20,000 students, you really want to get something that's battle-hardened and it is very solid, and Unix is that. You don't have to reboot a Unix server, more than once a year, and that's just for major updates and upgrades. Linux is a derivative of Unix. It's open source. It's free, and the sort of claim to fame is that it's a very thin and light operating system. The downside is that nobody knows how to use it. You were all trained on Windows, and so are you ready to make that conversion? You can still click through. There's a mouse and a graphic user interface, but many people are very comfortable, just like we talked about in the open office exercise. Many people are very comfortable with what they've learned, and they're not looking to learn an entirely new operating system. So when we look at application software, there's really 3 different types of software, right? There's vertical software and horizontal software, but when we look at this, our real options is buying something that's off the shelf. So going to Staples, going to Best Buy, and buying a piece of software, dropping in the CD and saying next, 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 install, 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 and then bring that forward and saying, okay, I'm going to run this the way it is. And then the other opportunity is to do something that's custom developed. So you may look at an application like QuickBooks and say, well, I need to customize this for my bank, for my clients, for my customers, for my invoicing schemes. And the third kind is one-of-a-kind application software. And this is designed for a specific need. The IRS might be an example. Military software is often an example. The U.S. Army wants a piece of software to talk about troop deployment and logistics of moving tanks around. Well, many people don't need software around moving tanks, in and out of third world countries. Well, this is what the military is going to do, and they will build and order specific software that does this. And sometimes you get a hybrid software, something that's designed for a large customer, but can be customized. So if you look at SAP, you look at PeopleSoft, these are software packages that do everything and do nothing. They're giant open frameworks. And if you decide that you need accounts payable or accounts receivable or HR, or you want some kind of time card system, you can turn these modules on or off as needed. And that's a good example of hybrid software. Now there's 2 ways that we can look at software. One is through a thin client and one is through a thick client. Now a thin client requires nothing more than a browser. Facebook is a good example. You don't need to install a Facebook application. You can go to any computer, yours, your friends, your grandmother's, and you go to facebook.com and you're able to log in and update your status, play your Farmville, do whatever it is that you want. Whereas a thick client is something that would run like a whole computer, and it would run Microsoft Office. If you go to a computer that doesn't have Microsoft Office, you can't open up an Office document. You can't edit one. You need to have the CD or the download from Microsoft Office. So the upside of the thick client is often it's more sophisticated. It's able to do more things. That said, there's more expense in administration to run it. You've got to have a DVD, you've got to load a DVD, you've got to patch the software, you've got to keep it up to date. You've got to keep all that running. Whereas a thin client, well, it's updated automatically. Facebook updates their website, MySpace updates their website, Amazon updates their website. When you log in, you get the new update. You don't have to do anything. At the end of this chapter, we talk about viruses, Trojan horses, macro viruses, and things to sort of take care of security. The book is going to differentiate, and so it'll be good to know for the exam and in reality sort of the differences here. But a virus is basically a program that's going to replicate itself, and it's going to do damage through something called the payload. If you thought about a rocket or a bomb, the payload is the part that does the damage. Virus is the same thing. It's the payload that's going to do the damage. Now, Trojan horses are viruses that are going to pretend to be something else. So if you're illegally downloading music and you download what you think is a music file, but it's actually a virus, you go to play it and it installs on your computer. That was a good example of a Trojan horse. You thought you downloaded a good MP3 and it turned out to be a virus. Macroviruses are something we saw about 7 or 8 years ago that we don't see many anymore. But they used to attach themselves to Word and Excel documents. And since those were the most common attachments that people would send back and forth, you'd have a document and it'd have this macrovirus sort of embedded in the side, and you'd attach it, you'd send it to someone at work, you'd send it to a colleague, you'd send it to your professor as your homework, they'd open it up, and then they'd have the macrovirus. And then every time that person sent out a Word doc, their programs would be infected, and now they'd have that problem. Worms are things that propagate using the internet. They're usually programmed to spread, and often you'll find that these are known exploits. That what worms are doing is there are known vulnerabilities in a program, and the vendor hasn't patched them or users haven't patched them, and that's the vulnerability that's been executed. The SQL Slammer worm of about 4 years ago was probably one of the most famous sort of recent worms that was out there. And that was something that was exploiting a hole inside Microsoft SQL, and it was a hole that Windows had patched about 6 months earlier, and it was just that IT people hadn't implemented that patch yet. And so because of that, this worm was able to go in and take administrative control of the server and basically start launching a worm attack. To prevent yourself from worms and viruses and Trojan horses, you want to make sure that you have some kind of antivirus. You want to make sure that you're doing Windows updates or Mac updates, that you're regularly checking your programs for patches. You don't want to download files from unknown sites. You don't want to open attachments from strangers. And you want to stay away from files that have been known to be problematic, like zip files and other things that often, if you click to open, you don't know what's inside that file until after you've opened it. If you can't get an antivirus program, I'd recommend going to free AVG at download.com. It's a great program, it's free, and it will keep you protected. That's our micro lecture. Have a great day.